Hello everybody and welcome to today's From Wi-Fi Insights, How Big Data from Your Wi-Fi Network Will Lead to Better Business Analytics webinar. Before we get started, here are a couple things to keep in mind during the presentation. This webcast is being recorded and the recorded version will be sent to you in a follow-up email early next week. We will conduct Q&A throughout the presentation, and it is our goal to make this a productive and worthy of your time. So we'd like this to be a discussion rather than a lecture, so please put your questions in the Q&A box and we will answer them as soon as possible. You can enter a question at any time. Now I'll take a minute to introduce our topic and our speakers. The topic is Wi-Fi is pervasive and has become a way of life. When you go to a friend or relative's house, it's not uncommon for someone to ask what the Wi-Fi password is before they even say hi. So although this is an interesting cultural phenomenon, Wi-Fi data can be used by business to improve insights. By aggregating Wi-Fi data with traditional data in your organization and applying predictive analytics, you can have a tremendous impact across retail, schools, healthcare, manufacturing, and just about every other industry. My name is David Sweenor, and I am calling in from the Green Mountain State, and I will be your moderator for today. Milind Pansare has over 25 years of technology experience, and he's worked at several Silicon Valley tech companies, and he is calling in from the Golden State. Jeremy Melville is a senior data scientist at Statistica, and he's been in the business for over 20 years and also has a wealth of experience. So with that intro, Milind, I'm going to pass it to you.
Thank you so much, David, and welcome everyone. Good morning, good afternoon, or good evening, wherever you might be from. And David, if you would pass the ball over, I can get started.
There we go.
Perfect. Thank you. So before I get started, let me just quickly introduce, for those of you who may not know Aerohive Networks, who and what Aerohive is. So we are the largest, the fastest growing enterprise Wi-Fi provider and one of the top 5 enterprise Wi-Fi networking vendors in the industry. So, just to give you a flavor of where you might encounter Wi-Fi from Aerohive, if you're in any of the largest school districts in the United States or in the UK, most likely you're using Aerohive Wi-Fi. If you're in higher ed and colleges at Oxford, Cambridge, you might be using Aerohive Wi-Fi. When you walk into a Chipotle or have your chicken sandwiches at Chick-fil-A or go banking at PNC Bank, those are a few of our customers, over 25,000 enterprise customers, and we make a full line of access points that provide Wi-Fi as well as switches for the access layer. We partner with Dell, Statistica, Juniper, and most of the switch vendors as well. So with that brief intro, let's get right into the topic of Wi-Fi. We often say mobility has changed everything, but what it's really done is it's changed the approach to providing enterprise Wi-Fi, and in fact changed the approach to what you're doing with the access layer network. So that network has been transforming from a connectivity network to more of a sensor network. And I'll talk about that in just a minute, right? So, to give you some examples of what's going on, it's perhaps more evident and fastest in the retail segment is what I've seen, is where Wi-Fi is being used increasingly with analytics. And the reason this shift is happening is very clear because brick and mortar retailers need to be able to compete with some of the advanced tools for customer acquisition that are available online. So if you're in brick and mortar, retailers have been in trouble for many years. And what they need to do is really achieve an omni-channel strategy for retailing. What this means is that you need to know who the customer is when they walk into your store, and whether they choose to engage with you or whether they're just anonymous, you kind of need to know who that connected customer is because they're traveling around with these devices. And at some point, they're either connecting to your Wi-Fi or sensing your Wi-Fi, and therefore you know that they're present in your store. You could know where they're moving. And so the use cases that you can use Wi-Fi for, whether you provide guest Wi-Fi or not, is to essentially personalize the engagement with that customer and then increase the loyalty and retention, provide a good guest experience, and last but not least, make your business more intelligent so you can adapt to the people walking into your brick and mortar store locations. Let me give you a couple of examples of that. So I am wearing, in fact, yes, I am. Today I'm wearing my shoes from Clarks. So if you are, Clarks is a great footwear brand, and if you're walking into stores in the UK, for example, that sell Clarks shoes, again, they use Aerohive Wi-Fi, but one of the things that they are working with and trying out is how do we engage those customers. So, you know, when you walk around with your phone, unless your phone is in airplane mode, typically your phone is looking for a Wi-Fi SSID. And when that happens, your phone is basically able to be detected by the Wi-Fi. So what information you have is how many people are walking by your store, how many people entered your store, and then once they did, you can even actually track how many people are walking around in what pattern in your stores and what displays are they standing in front of. If you have a few access points, you can triangulate the location. Once a person actually joins your guest Wi-Fi or downloads, often retailers, what they're doing now is that they'll provide you with a coupon or something that can go in your Google or Apple wallet on your iPhone. Once that happens, you can actually start to push advanced information. So you can say here, you know, you're walking by a flagship store, we're going to give you a 20% discount. So retailers are playing with these kinds of approaches to maximize revenues. The kinds of business insights that you can get out of Wi-Fi data include things like capture rate. So like I said, you know how many people are outside your store. You know how many of them came in. You can figure out what their dwell time is. You can figure out then if you were able to marry this with additional data sources, and Jeremy will talk about that in a little bit, in terms of opportunity and your CRM systems, you can now correlate that dwell time with your revenues, and then you can do historical trend analysis as well. So again, these are the kinds of approaches that will enable brick and mortar retailers to effectively compete with their online counterparts. In quick serve restaurants, you know, Nando's, again, a very well-known chicken franchise, they had a challenge with queuing time. So, you know, your store gets slammed at certain hours, maybe after the nightclubs are out or whatever the case might be. And all of a sudden you have these long queues. Well, that's not a great customer experience. And so if you're able to actually detect that flood of people coming in, you can then be more intelligent about how do I allow for better capacity at certain hours and therefore have a better customer experience. Let's take a look. I mean, it's not just happening in retail. You might be surprised to know that in classrooms, Wi-Fi and the data from Wi-Fi is actually being used to improve the learning experience. So let's talk about how that could happen, right? Now, in K-12 schools, there's a lot, obviously Wi-Fi is very critical because all students are connected. In fact, in schools now, you know, the average number of devices coming into a school is 2.5. I don't know what the 0.5 is. Maybe that's my kid's broken iPhone. But, you know, that's the average in the United States, at least, in terms of number of devices walking in. So it's school-issued Chromebooks, iPads, the kids' own devices. How do you use those to ensure a good learning environment? How do you make sure that it's not distracting from learning? And then last but not least, how do you use data from what students are walking in, their attendance, etc., to provide predictors of students that might be at risk of dropping out. And in fact, as you go to higher education, where students dropping out becomes an impact on revenue for colleges, we have examples of customers who are in fact looking at attendance as a leading indicator for whether that student might drop out, and then by combining that with other data sources, and Jeremy, correct me if I'm wrong, you do have a demo where you can show us this as we get along, correct?
Yes, that's correct. So what I'll be showing today, so this is Jeremy, it's very nice to be here today. So we have a demonstration that takes the attendance rates for students with the partnership of Statistica and Aerohive. We're able to combine a lot of different types of data sources together, including the location-based data sources, and be able to be proactive in retaining students, so applying predictive and prescriptive analytics. So more on that later.
Great. Well, I'm looking forward to that. So again, these are very real use cases in terms of being able to generate revenue in higher ed, but also in terms of being able to identify and help students who might be in need of additional intervention and support in K-12 education. And using attendance data, because you know what kind of devices they're bringing in and whether their devices connect to Wi-Fi and at what times of the day, you have a fairly good sense of what's going on your campus. So that can also be used for security. But let's move on to hospitals, for example. So we have large hospitals and large long-term care providers who are our customers, people like Memorial Hermann, for example. And again, there's many use cases here in healthcare. So you have a lot of devices now that are connected to Wi-Fi that are used for monitoring various health signs, whether it's just non-critical data like your blood pressure and your temperature. When you come in, there's usually one of these mobile little stations, and these things move around. So when they move around and you need a critical piece of equipment, they're all connected to Wi-Fi, and they can be located using location and presence information in Wi-Fi. So that's one example of how you can use almost an IoT use case, which is really happening in healthcare. But then you can also use it to smooth the entire patient check-in experience. So when you have people coming in as outpatients, you can check them in very smoothly when they drive into your garage. If they've already accepted your Wi-Fi terms and conditions, now you can sense when they're in and improve their experience. Jeremy, I believe you've also looked into how this can be used in claims management and fraud detection, and that was kind of interesting when you talked about it. Do you want to touch on that?
Certainly. So it's not just within the hospitals itself, but also with claims management and fraud detection, applying predictive analytics and different anomaly detection algorithms to perhaps detect fraud, using and also being able to use the location-based data for claims management to understand whether the patients were at the locations that they were that they said they were at that time. So it's quite a lot of interesting use cases combining the location-based data with other data available at the hospital.
Fascinating. So, you know, let's just switch to a generic enterprise, though. In most enterprises, I mean every enterprise, Wi-Fi has become the primary mode of connection now. You rarely ever go in and dock your laptop into a docking station anymore or use a wired cord. You're typically on one of the enterprise Wi-Fi access points, either as an employee or as a guest when you go visit. What this can help you with is to actually create smarter working environments. You know, besides what you might expect in terms of the guest experience. And in fact, we've seen some customers doing really fascinating things. You know, we talk about IoT. There's today probably 6 billion endpoints that are connected to the internet that could be classified as IoT, and that's expected to grow exponentially. And these could be anywhere from small sensors that are, temperature, pressure monitoring sensors, and humidity monitoring sensors in quick serve restaurants, for example, or in your own the thermostats in your offices, or the video cameras. The vast majority of them are using Wi-Fi for access. If not for the individual devices, then there's typically an aggregation point, and that aggregation device then is on Wi-Fi or on a wired port on your network. So there's a lot that you can do because these things are on the access layer of your network. And one good example is, for example, Deloitte has this smart building. Deloitte's one of our customers. And it's fascinating to know, this one's in Europe, that in this building they have over 40,000 sensors, and they have 6,000 IP addresses just for their lights. And what are they able to do with this? Well, what they're able to do is, based on location presence and other data, they are able to do smart office, hot desking, for example. So, has that conference room been used today or not? Is there a need to go clean out that conference room? Should we turn down the lights? Should we, based on temperature, turn up the AC? Should we, assign a desk to a particular person down in the ground floor, and then make sure we just use 2 floors of the building today because there's fewer people in the building, and we don't have to use up all the energy in the other parts of the building. So really fascinating things that you can do for business efficiency. So just another kind of use case here. So, given all this, how do you actually get around to unlocking the potential of Wi-Fi? I gave you a few examples here. So, to understand that, you have to understand a little bit of an evolution that's taking place in Wi-Fi. It used to be that Wi-Fi vendors were trying to differentiate based on speeds and feeds. My antenna is better than your antenna, or I've got the latest chipset. But guess what? If you're one of the large enterprise vendors, we are all buying chipsets from the same, same 3 or 4 chipset manufacturers. And yes, there's some differentiation in technology. We have differentiators like dual 5 gig radios, etc. But increasingly, that differentiation shifted over the last few years to architectural differences. For example, do you have controllers, or are you distributed control? Do you have a cloud network management system to simplify operations? And the newest trend that's really happening to differentiate between vendors now is insights and analytics, which is what kind of APIs or application programming interfaces can you offer to move that network from a connectivity network to a network of insights, or a network of sensors, if you will. And that's where partnerships with Statistica, for example, become extremely important for Aerohive, where insights and analytics combined with the Wi-Fi data can really provide you that business value. Now, to give you a sense of the scale that's needed for this transformation, all of a sudden it's not speeds and feeds in the radio anymore that are important. But if you look at Wi-Fi data coming into the cloud now, when your devices are connecting, or your customers are walking in to your stores, or employees in your offices, you can get over 1 million data points every second. So in order to support data of that kind, this is truly big data, you need to have an architecture for your cloud, whether it's a public cloud or private cloud. In Aerohive's case, obviously we have customers who require the security of a private cloud, and we provide the exact same interface, whether you're public or private. But again, you need an architecture for that cloud that isn't just about network management, but is about big data storage. So you need to have, a Hadoop backend, for example. You need to start thinking about Spark processing engines. So it's no longer a network management system, but it now becomes a big data system. It needs to be able to take data coming from the access points and the switches, from both us as well as partners like Dell or Juniper switches, and then you need application programming interfaces that can clearly offer you via webhooks or APIs or RESTful APIs a way to be able to tap into that data. And what kind of data am I talking about? Location, presence, identity, configuration even, and monitoring. So you can see, for example, these access points actually have deep packet inspection. So in a school during business hours, if you want to throttle down Facebook video because it might be distracting, but keep YouTube video at a high quality of service during school hours, you can do that by using the APIs for monitoring. And so you can build a whole bunch of applications that go beyond the network management system. So our network management system, Hive Manager, is built on these APIs, but there are customers who build their own applications or even managed service providers who want to create new dashboards that these APIs can now enable. On the flip side of that, though, the trend we are seeing, and this is happening with retailers, is that they're now looking at business value. And this is where integrations with Statistica that Jeremy will talk about in a minute bring out the business value and with the advanced analytics and the predictive analytics capabilities that are possible. So with that, Jeremy, let me hand it over to you, if you will, and to talk a little bit more about Statistica.
Fantastic. Thank you, Milind. So I thought we'd spend a little bit of time introducing people on the phone here to Statistica. And what I'll do also is show a brief demonstration of our partnership with Statistica and Aerohive, showing how we can combine the location-based data with other more traditional forms of data in a couple of use cases. So before the demonstration, I'll talk a little bit about Statistica. Statistica has been around for quite some time now. It's since 1984, and it is a very full-featured predictive analytics, advanced analytics platform. It's an enterprise-level platform and has a desktop component as well as several big data enterprise components as well. It's a very open platform, easy to use. You don't need to know any scripting. You don't need to script if you don't want to. And it has a lot of different functions available to you, being able to conduct anything from decision trees to clustering, forecasting, pretty much you name it as far as advanced analytics is concerned. So it covers anything from the basics of data collection, business intelligence, reporting, dashboarding, all the way through to the increasing maturity of an organization, getting into more predictive analytics and prescriptive analytics. So using mathematical algorithms to predict what may be happening, could be happening in the future, but also in integrating business rules in prescriptive analytics and assigning some type of intelligent action according to the different use case involved. So with Statistica, we cover a lot of different areas. It is an easy-to-use predictive analytics platform. We have data blending or data preparation, data management capabilities, as well as the ability to connect to a lot of different data sources. It is an open system, so we have pretty cool integration points with Aerohive, integrating with their APIs. I'll show you how that works shortly. We have a data discovery and visualization tool, a dashboarding tool. We have real-time analytics. We're able to provide an infrastructure to collaborate and share, combining the business rules and analytics to make prescriptive decisions. We also have a lot of security and governance capabilities for version control, auditing. We operate quite heavily in the pharmaceutical and manufacturing industries and a lot of highly regulated environments. Very open system, and I'll talk a little bit about in-database analytics and edge analytics. And as the common theme through this presentation is also big data, and as Melinda had touched on, there are a lot of data being generated all the time. Statistica has quite a lot of interesting capabilities as far as big data is concerned, anything from in-database analytics, using Statistica algorithms to execute within big data platforms, but also the notion of bringing analytics to the data. So we are able to transport our analytical algorithms to perhaps a gateway or even a particular devices in an IoT or Internet of Things environment. This is via a RESTful API service, and the benefit of doing this is that we can use the model management and governance capabilities that Statistica has built up over the 34+ years that it's been around, and bringing the analytics to the edge of the network, and also being able to, of course, communicate with other APIs such as the Aerohive data sources. So what I'll do now is switch to my local machine and give you a bit of an orientation of Statistica, but also talk about the use case where we have had partnerships with Aerohive. I'll be focusing on student analytics and also talk briefly on a retail use case. So this is the Statistica interface. So we can script in a lot of different languages. You can use the workflow user interface if you don't need to know any scripting. We have a lot of data preparation management capabilities, a lot of charting, different data mining algorithms, as well as advanced and basic statistics. So the first use case that I'd like to go into, I'll be showing this through the Statistica interactive visualization dashboard. So this would be the end product of an analysis. What we've done here is taken the Aerohive location-based data and combined those data with regular student records, regular student data. What you're seeing here is a breakdown of students who have stayed with a program, or students who have in the past dropped out. If they've dropped out, they have a retention of 0. I'll just drill down into that, the students who have non-retention in this case. So we can see the breakdown of the types of students who have left the program early, and you see here nursing and business administration and undeclared students, probably towards the top of the list. We can also drill down, of course, into the different areas and understand how the different locations across the state may be performing. But what's quite interesting here is that we can start to introduce more advanced or predictive algorithms within our analysis. We don't need to do basic business intelligence, what is happening in the past, but also understand what could happen in the future and also provide some prescriptive actions to take. As an output of a predictive model, I can see here that things like the GPA score and the degree program are the top 2 factors that determine whether a student is likely to stay or leave the program. But also we have attendance, which is an important variable. The attendance is derived from the location-based Aerohive data, comparing that against the student schedule for attendance, and an attendance rate is automatically generated based on the Wi-Fi presence data and when the students are likely to be in the course. So a student is marked as attended if they're in the class that they're supposed to be in for at least 10 minutes, I believe. So we also can, so interestingly, attendance is a big factor, but we can also perhaps focus on the students that are at higher risk. So just filtering to those students, we can see with the student ID the students who are at higher risk, together with their some information about them, about their performance. But quite interestingly, we can use the prescriptive analytics to provide a recommendation based on the student's status. So looks like there are some students there that are at high, slight, or extreme risk, which are based on business rules that are implemented, and possibly what can be done about that. So using the data and the algorithms, it may be determined that a student would be leaving because they're having trouble paying for a particular class. So it may be that we offer some support for paying, or it could be that they would require some more focused tutoring in particular areas. So combining the location-based data, the predictive algorithms, and also the business knowledge that the staff have gained over the years, we can provide quite a powerful recommendation engine. So this will give us some good actionable insights that really make a difference and retain the students, thereby increasing the revenue for the institution. And another interesting, there are a whole set of different types of output that we can generate through our predictive models. And one of those outputs in this particular model, this is a tree-based model, is a tree graph. And we can see here that we can start to build up some business rules to say that if a student has a GPA of less than 3.1 and their attendance is below a certain amount, then they're more likely to leave, they're more likely to at risk. So we can also use the predictive algorithms to come up with some interesting business rules to watch out for at-risk students. I thought I'd show a little bit about the data, and this is a statistical workflow. We have some integration points with Aerohive where we can communicate directly with the RESTful APIs that Aerohive has to give us this type of information. So this, things like the student MAC addresses and the locations of where they are, perhaps the classrooms that and the different gateways that they're connected to. So we can combine that with regular student-based data and use other data such as the schedule information to calculate attendance, execute predictive models to then come up with some type of probability score of retention. So for each student, we come up with a score, then we can implement some business rules that will give us some type of prescription for action. On another use case, just very briefly, quite often in retail marketing, we may have a situation, this is a simulated, very fast simulated environment that's just showing the information collected from Aerohive, and we may have a map of a mock-up of a map of a store, and we can track to see the traffic and how people are, how much time people are spending on each of those at that location. And we can also combine that with different multimodal advertising techniques. So it may be that we may be interested in looking at different store performances and having some type of predicted performance or predicted foot traffic as well as revenue for the day using advanced analytics, and comparing that to actual events in order for us to properly plan out. And that expected traffic and the actual traffic can be derived through the Wi-Fi data automatically for you. Then being able to drill down into the different stores, and also combine that with other types of advertising. So we may have more digital advertising campaigns using predictive analytics to target and personalize advertisements, and then track the lift gain by the targeted digital advertising. So there's a lot of opportunity there for retail, and combining retail with the location-based data with advanced analytics for a truly personalized experience, and to better understand how your different retail stores are performing. I think that's just a brief demonstration. What I'll do is pass it back to might be David, who will be and we'll be asking about talking about some perhaps some Q&A if there are any questions, and we can happy to answer some of those.
Yeah, thanks, Jeremy, and thanks, Milind. That was a great, overview and demo. And, Milind, I think the 2.5 devices matches right up to the 2.5 kids per household. Jeremy, please sign me up for the Win Red Sox ticket campaign. I want to win those. And you, being from the Empire State, will probably be happy to give those away to me. But anyways, we have a lot of questions coming in, some really good questions. I know some of them have been answered in real time, but I'm going to ask some out loud, and we'll just keep them coming in the Q&A panel, and we'll get to as many as possible. So this one question is, how is a person in the era of Wi-Fi access point detected? Is the MAC address that is identifiable, or the device name? And is there a way to remember that unique identifier so we can tell when a customer returned?
Yeah, I can take that one. So, and there's a related question around MAC randomization, so I might as well touch upon that as well. So, there's different levels of information that's available to you depending on the amount that the person chooses to share with you. So what do I mean by that? So when you have your, let's say, just an iPhone, because I have one of those, when you're sitting on an airplane, you typically turn it in airplane mode, and you may or may not, these days, you turn on your Wi-Fi because you're trying to connect to the United or whichever airline's Wi-Fi. But even unless you've actually switched it off, normally when you're walking around with your phone, you have Wi-Fi on because it helps you improve your location accuracy. So as you're walking around, your phone is constantly pinging every single access point as it passes by, trying to say, hey, this is me. Is there an SSID that I recognize that I can hop onto? And then the ones that you remembered, you automatically join. So let's say you're a retailer and you've provided guest Wi-Fi. And let's say you have multiple brands. As you go from one brand of retail, let's say you're in the grocery store, to that same company's other location, which might be a baby, a child, a baby store, for example, and this is a real example in Europe of another retailer. if you've already accepted the terms and conditions, you automatically hop on to the same SSID and the same Wi-Fi. So now you're connected. When you're connected, so before you were connected to the guest Wi-Fi, we at least know where your location, what your presence is, and your location if you can be triangulated by 3 access points. Once you're actually connected, then information like your MAC address, etc., the kind of device, the OS running on it, the kinds of applications are all known to the access point as you're running them, because the access points, enterprise access points, will do deep packet inspection, so they know what kind of traffic is coming in, can recognize the signatures of that traffic, and tell you, is this person on Facebook video? Are they on GoToMeeting? Are they doing a WebEx? What have you? Are they doing Salesforce? Are they connected to Box, and so on? So that's one part. The other part about the randomized MAC address is, that is, so for those who may not know, iPhones and Android devices randomize the MAC address to essentially make it impossible for people to, for exactly this reason, to protect the anonymity of people if they haven't attached themselves or haven't hopped on a guest Wi-Fi. And there are algorithms to figure out, at any given time, how many devices there are. The next second there might be, it might change its MAC address, but you still know at that next second how many devices there are totally. So you know what kind of traffic is there, and then there are algorithms to kind of try and guess if it's the same device. So again, there's a lot of stuff that's done for location and presence to get around those kinds of issues. And of course, all of this has to be done protecting privacy rules. And so, at each layer of this, whether it's Wi-Fi and the next layer where there's analytics, or the next layer where there's the business rules of a company, you have to follow what the prevalent privacy laws might be in every single country. So again, there's a lot of information, but also a lot of things to look out for.
Great, thanks, Milind. This is probably a question for Jeremy. There's a couple of related questions. So one is, can the Statistica software take data directly from an existing database? And there's also a related question on, what kind of data is available, to supplement with your in-house data from the Wi-Fi network.
Certainly, yeah, great question. So the types of data can be quite wide-ranging. So we traditionally take data from relational data sources, even file-based data sources, but we can also connect to more non-traditional kind of NoSQL type data. So we have a lot of flexibility as far as the types of data. We can connect to your databases pretty in quite a straightforward fashion. Certain databases, we can actually execute some of the analytics on the database itself without having to take the data out of the system, which is quite beneficial when you have large data sets. And you want to leverage the power of these big data database engines. And we have a very open system, so we connect to API-type data sources, of which Aerohive provides data through a RESTful API web service, and then combine that with as far as the different types of data. So the different types of data can be anything from demographic information, transactional, any kind of information about whether it be a customer, a patient, any kind of entity that we're trying to analyze.
Okay, great, thanks. There's a few questions, Milind, on Bluetooth versus Wi-Fi. I don't know if you can touch on advantages, disadvantages.
Sure. So typically when you're doing location through Wi-Fi, The advantage of using Wi-Fi, firstly, is that it's pretty pervasive, and secondly, that the access points are typically fixed to something, right? They're either on the ceiling or they're in a location that really can be fooled around with. But in retail, you do see people using Bluetooth beacons because they can give you immediate proximity information. So, for example, if you're looking for very, very accurate, like if somebody's standing right in front of this display, you might see retailers trying to use that. And that's one of the reasons why in our access points, we also have BLE available, and we have a USB port so people can add all kinds of devices that they might use or other things that might be, and put it in just one place. But increasingly we find, I mean, one of the issues with Bluetooth beacons is these are small, the batteries run out, it's a headache to manage them. So what we are finding is that people, you know, and unlike Wi-Fi access points, which are powered over Ethernet from the switch directly, so you don't really have to worry about batteries running out and things like that, or hippie, you know, kids running away with your BLE beacons. And moving them somewhere else. So again, both approaches are used. You know, beacons, BLE can give you slightly better location information, but if you are looking for something that's less of a hassle to manage, Wi-Fi gives you good enough location for most use cases, and most people aren't doing precise locationing. What they're doing is presence. You know, how many people are there in the store right now? Right, that could be valuable as opposed to, you know, most people don't know what to do with data about where is this person in the store. You know, there might be use cases for that, but I don't see that too much yet.
Okay, great, thanks. There's a question related to the demo, Jeremy, on the university. It said, so you conclude they dropped out because they haven't been connecting to the university Wi-Fi network. Comments on that?
Yes. One of the projects that we were working on, it was a requirement for the students to connect as far as their attendance is concerned. So instead of the professor marking off the attendance sheet at the start of every class, it was asked of the students to connect to the Wi-Fi. And of course, there will be some students who either don't have a device or are unable to connect for some reason. And for those cases, the other variables that go into determining whether a student is likely to leave will come into play a little bit more heavily. And when a student is identified as being at risk of leaving, of course, we'll look at the attendance and talk to the student about whether that is certainly possible. This is used as a guide for decision making, but it's not something that is going to automatically make some type of decision for someone. It's just as a tool to help them.
Okay, great. And this question, I don't know if this is too technical or not, but maybe a joint question here. It says, how do you map the dots inside the building if the user's not connected to the access point? Are the access points able to triangulate position and overlay it on the store map?
Yeah, in fact, you know, when you're looking at, and the use case here is footfall traffic, if you're trying to figure out footfall traffic and patterns and then correlate that with the map, again, the location data is dependent on how many access points can see you from where you are in the store, for example. So if there's 3 or more access points, you know, you get fairly good location data, and you don't have to be connected to the Wi-Fi. That's just, as I said, you know, your phone trying to get on Wi-Fi. That gives you that data. So now to correlate that with the store, etc., you can consume those APIs. And in fact, we have solution partners that do that. So there are other retail analytics partners, for example, that do specifically that, provide just a verticalized solution for retail, and they'll map it onto footfall traffic using our APIs and general store maps and stuff like that.
Great, thanks. There's lots of questions on it. The slides will be distributed. Yes, they will be in the link for the solution brief. I will put that in the chat window so everybody can have that. Take a look at that now. I guess I'm not seeing any more questions, so I'd like to thank everybody for their attendance. I'd like to thank Milind and Jeremy for the excellent presentation. And so if you have any questions, feel free to reach out to Milind or Jeremy or visit the websites, and we'd be happy to help. So with that, I'd like to close this, and I hope everybody has a great day. Thanks for your attendance. Bye-bye.